So to start off, we're asked a question. It says, Lucas lives near a calm stretch of the Cowichan River. Today, the speed of the current near Lucas's house is 1 kilometer per hour. Lucas puts his canoe in the water and paddles 5 kilometers downstream. He turns around and paddles 6 kilometers upstream to his grandfather's house, who lives on the river. The whole trip takes Lucas 3 hours. What should Lucas's canoe speed be on the still water of Lake Cowichan? Okay, so we're given quite a bit of information here. As you can see, I've already taken the liberty of highlighting the important parts. This being the current, which is 1 kilometer per hour. And then we have other information such as he paddles a total distance of 5 kilometers downstream, 6 kilometers upstream. The total trip takes Lucas 3 hours. And our final question is, what should Lucas's canoe speed be on the still water of Lake Cowichan? Okay, so kind of just piecing together this, I have all these highlighted pieces of information. We do know that speed is distance divided by time. However, we don't yet know the speed. However, we do know the time, as the time is 3 hours for the total duration of the trip. I've kind of just drawn like a silly little sketch here. So we know that when he's traveling downstream, the current is pushing him 1 kilometer an hour in addition to his current speed, which is unknown at this time. And then when he's traveling backwards or traveling upstream, he's having 1 kilometer of current going against him. So what I've done here is I've taken our formula, speed equals distance times time, and I've changed it around for what we do know. What we do know is that the total trip took him 3 hours. So I rearranged the formula to be time equals distance over speed. So we don't yet know the speed, but we do know our time and our distance. So I rearranged it. And this is for when Lucas is paddling downstream. He travels a total distance of 5 kilometers. And he has that little boost from the current, which is 1 kilometer per hour. So I'm putting X as the speed, which is unknown, plus 1 kilometer per hour. And then for the trip upstream, which is a total of 6 kilometers in terms of distance, I'm putting the speed as X minus 1. And I know that this all has to be equal, the sum of these two has to be equal to 3 hours for the total trip time. So that's how I got the equation itself. And then if I just remove some of these, we can do all the fun math and we finally get our answer. I'll let you just kind of go through this. I'm not going to explain all the steps. We get 2 speeds, or 2 possible speeds. One is X equals -1 over 3. So we do have to reject the solution because he's not going to have a negative speed. And our other answer is X equals 4. So that would be 4 kilometers per hour. So going over, we can see that if we plug it into our original equation, we plug 4 in for X, or 4 kilometers per hour, and do the math and cancel some units. 3 hours equals 3 hours, so we can verify that that is correct. 4 kilometers would be his speed, assuming that there's no current. So for speed on Lake Cowichan, Lucas's speed will be 4 kilometers on the still waters of Lake Cowichan.